Okay, we're going to learn about exponential growth and decay, which you've probably heard a lot about. Sorry, my chair is squeaky. Heard a lot about in science, or maybe you haven't gotten to that yet, but you will, trust me. There's going to be 4 different formulas today. So like I said, I am going to let you, either I'll give you the formulas or let you use your own formulas, probably give you them. But for now, put them on a note card. So we're going to have one for exponential growth, one for compound interest, one for exponential decay, and one for half-life. Okay, and then one problem to go with each. And with these problems, the most important thing is knowing how to substitute values in, the right values, how to figure them out, and how to use your calculator. So let's first get our definition down. Exponential growth. It occurs when a quantity increases by the same rate r in each time period t. So the formula for that one is y equals a times 1 plus r raised to the little t. And you're going to have a little work here to write all what these mean down, but it'll be worth it to you to have this to refer to, trust me. So y is the final amount of whatever they're referring to. A is the original amount. We can't say of what because we don't know what the problem is yet. R is the rate of growth. And that is always written in a decimal form. And not percent. You want to always take the percent and change it to decimal. And T is the time. Okay, so let's take a look at one. The original, see these keywords, the original value of a painting is 9,000. Oh, so which one would that be here? The original value of the painting is 9,000. That's going to be your A. Yeah. And the value increases by 7%. So that's the rate of growth. That's how much it is growing, the value. But it does say to put it in a decimal. So I'm going to take this 7% and I'm going to put that in a decimal. And that is my R. Remember to change it, you just move it 2 spots to the left to get it into decimal. And it says write an exponential growth function to model the situation. Okay, so basically it's saying take that information, put it into here, and tell me what you get. So I get y equals A, which is 9,000, times 1 plus the rate raised to the t. So we're going to add those because they're in the parenthesis. I'm going to do that first. There. That is an exponential growth function right there. So that's the first part of their question. Then they said find the painting's value after 15 years. Okay, that is your t. So again, we put that right in there. Y equals 9,000 times 1.07 raised to the 15. And we've been doing a few of these, but I still want to make sure you got this down with the calculator. So we put the 1.07, use your y to the x button, find it on your calculator, raised to the 15 equals, then multiply it by 9,000. Equals. And I got, let's see here, $24,831.28. Whenever it's money, always go out to the cent, which is the hundredths. Okay? All right, compound interest. So there's simple interest, which you guys have done already. That was pretty straightforward. It's just a value, it's just times the amount. Compound interest is a situation in which interest earned or paid, depending on if you're loaning out the money, or if you are getting the money. or loaning it from somebody else, borrowing it from somebody else. All right, interest earned or paid on both the principal and the previously earned interest. Okay, so simple interest is basically, okay, you have $9,000 times 6%, multiply it, done. But compound means that, okay, so let's say you get an interest every 3 months. So in 3 months, they take what's in your account, they multiply it by the interest, and you get that amount. Well, then 3 months later, when they take the interest, they take the percent of not only the principal you put in, but the new interest that you just earned 3 months ago, and then they get a new value. So every month they base it on your newest balance that you have in there, not the original amount, and it's not just one set thing. So it's a little more complicated. It looks like this, which can be a little frightening at first, but once you get all the different things written down, you should be fine. A is the balance after T years, so your T should be in years. P is the principal or original amount. R is the annual interest rate. And just like above, we want that to be in a decimal. N is the number of times interest is compounded per year. So it may be every month, it may be every 3 months. So if it was every 3 months, how many times would it be compounded in a year? 4. If it was every month, how many times would it be compounded in a year? 12. Okay, so you have to figure that part out. And then T is your time in years. Okay, so good notes is really valuable here. Write a compound interest function to model each situation, then find the balance after the given number of years. So kind of like the above one, we're going to substitute our values in. Let's read it first. 1,200 was invested. Okay, so when I look up here, which one talks about how much money was the original amount, how much was put in? P, the principal or original amount. So this is my P. At a rate of 2%. Which one talked about our rate? Our R. But remember, we need it in a decimal form, so we move the decimal over 2 spots. We get 0.02, and that is our rate. Compounded quarterly. So if it's quarterly, how many times a year? What is N? How many times a year does it get compounded? Quarterly means every 3 months. So that would be 4 times a year. So that means N is 4. That's what that information tells you. So let's plug that in. So A equals principal, 1,200, times 1 plus R over N, raised to the N T. They don't want us to put the 3 in yet because I think it's here it says then find it for the number of years. So that's why I'm purposely not putting that in yet. But we do need to get this number in here. So let's see what that is. So 0.02 divided by 4 plus 1 gives me this. You should be checking with your calculator to make sure. Feel free just to pause the video and try it out and make sure you're getting these right values so that when you do the homework it doesn't come out wrong. And now it says, okay, well, what do we get if it's 3 years of this? These are multiplied, mind you. So that's 12. And raised, I'm going to again use that key. Where are we here? Raised to the 12th. And then times 1,200. Looks like it's, again, money, $1,274.01. Okay? I think you should pause the video and see if what I work through in this next one comes out correct. That would be my recommendation. But I'm going to move through it right now. So 15,000 is invested. That's your principal amount again. That's the what you started with. At a rate of 4.08. Change it to a decimal. 0.048 is my R. And monthly means every single month for a year. So that's 12 times it gets compounded. And then I'll do this at the end like they asked. So A equals 12. Whoopsie, why am I putting that in there? The principal is 15,000 times 1 plus the rate over the n, which is 12, raised to the n, which is 12t. So again, you have to figure out that middle part. So I'm going to do 0.048 divided by 12 plus 1, and we get 1.004 to the 12t. Now they're saying, okay, go ahead then and figure it out for 2 years. Great, I will. 15,000, 1.004 raised to the 12 times 2. And now I'm going to take this amount and raise it to the 24th and times it by 15,000, and I got, money-wise, see here, 16,508 and 22 cents. I always round on that cent mark. All right, great. Well, we have 2 more. The next one is exponential decay. Okay, so we did exponential growth, we did compound interest, and now we're going to do exponential decay. So let's get our definition down and try one of these. So this occurs when a quantity decreases. Another one, of course, was increases. Decay means to get smaller by the same rate, R, in each time period t. So again, that's decreases, just to emphasize the difference here. And in growth, back on the other sheet, it was increases. All right, so I want to also have you take note of this formula on the growth, because watch how similar it is on the decay. So I'm going to leave them both on there so you can see for now. It's y equals a times 1 minus r to the t. So check that out. Pretty cool, huh? Makes sense though. This is decreases, so it's going to be getting smaller as the rate, and the rate is here getting bigger. All right. Let's put what they stand for so you have good notes all set up for you. Y is the final amount. A is the original amount. R is the rate of decay, again as a decimal. And T is our time. Okay, so population we're going to talk about here. Population of a town is decreasing at a rate of 3% a year. Got that. In 2000, there were 1,700 people. Okay, that looks like that's an original amount to me. So that's my A. Write an exponential decay function to model the situation. All right. So y equals A, which is 1,700, times 1 minus the rate, which is 0.03, raised to the t. So now we have y equals 1,700. And 1 minus 0.03, can you guys do that in your head? It's 0.97 raised to the t. it says, then find the population in 2012. Okay, well, they don't directly tell me T, do they? But you can figure it out because you can see how much time has elapsed. This was started in 2000, and they're asking about it in 2012. So that means our T is going to be 12 years. So we're going to plug that in for our time. And we're going to grab that calculator, which is our friend here. Now, this is a situation to use the calculator, right, kids? Not on 9 times 5. Okay, looks like, well, it's people. Again, this is a real life problem, so we got to think about what we're rounding to here. I'm not going to put a part of a person on there. Okay, so we're just going to round to the nearest whole person, which would be 1,180 people. And I would say, wow, their population dropped pretty severely, I would say, didn't it? Anyway, all right, moving on. Half-life, 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 half-life. You'll hear about half-life a lot if you get into the medical world. They'll talk about medications and how fast they move through your system. And they'll say, what is the half-life of that medication? So in other words, that means how long does it take for half of that to be gone, to decay? So let's get this down. So the time it takes for 1/2, so this isn't all of it, for 1/2 of the substance, whatever it may be, to decay into another substance. Okay. Formula for that is a little simpler. We're ending with the simpler one. It's P times 0.5 raised to the T. A is our final amount. P is the original amount, so it kind of follows through in these, doesn't it, similarly. And T is the number, this is the trickiest part. Okay, are you all listening? T is the number of half-lives in time period. This you have to pay special close attention to. It's not quite as simple as our other T's thus far. Okay? So let's take a look. Astatine, am I saying it right? I don't know, one of you probably knows. 218 has a half-life of 2 seconds. And a lot of the periodic table, I'm sure this is on the periodic table. So we should have our chemist here to help us. Has a half-life of 2 seconds. Find the amount left from a 500-gram sample of astatine. I feel bad that I don't know how to say that. 218 after 10 seconds. So let's take a look at this now. First of all, what's the 500 grams? That is right. That's your P. That's your original amount. So we have A equals 500 times 0.5. And we have to figure out the T. Now remember, the T was the number of half-lives in a given period. Well, here it's saying one half-life is 2 seconds. That's one. And they're saying, okay, we went by 10 seconds. So how many half-lives are there? So you have to take that 10 seconds, that total amount of time, and divide it by the 2. Because that will tell you that you actually had 5 half-lives here. Okay, because one half-life was 2 seconds. So in 10 seconds, you would have a total of 5 of those sets. And when you calculate that out, which I already did, it's 15.625 grams. All right, let's do the last one. Again, I challenge you to pause it, try it yourself, see if you got it right. All right, so the amount is still 500. So we're the same there, but it said this is now after 1 minute. So 1 minute is 60 seconds. You want to be talking of apples to apples, seconds to seconds. And so how many sets of 2 seconds are there in there? Because that's how many half-lives you'll have. 60 divided by 2 is 30. And your answer for this one is very small, depending on your calculator, how far it goes out. 1, 2, 3, 4, 5, 6. It's either going to be this, or yours might have rounded it and have 4, 7. All right, guys. I hope that is clear. I hope you have what you need to do well on today's homework. If not, feel free to listen to it again or give me an email. Take care. Bye-bye. God bless.